I can give you the following exercise. Let's consider the generator of the space of Jacobi cusp form of weight 10 and index 1. This is the Eichler-Zagier case. Then this function is equal eta function to the power 18 times the square Jacobi theta series. Then H10 phi 10 1 is equal to the function phi tilde 12 1, which is a cusp form of weight 12 and index 1, where the zeroth value of this function is equal up to the constant to the Ramanujan delta function in tau. In particular, 1 over c phi 12 1 tilde is a function phi 12 1 such that its particular weight is delta function. Please find this content. Our question is to find it. See. The second question. Let us take the function e for 1 in tau and z, which is the pullback of the Jacobi theta series for the lattice E8 for the root vector v. V is in E8, v to the square is equal to 2. Please try to calculate H4 E4 1. This is a Jacobi form of weight 6 and index 1. Please try to calculate its zeroth value. But now I would like to analyze an application of the result which we get. More exactly, I would like to use the second function and to prove the following theorem. You can find this theorem in Eichler-Zagier book. This is the theorem about the algebraic structure of the graduate ring of the weak Jacobi forms of even weight. By definition, this is a graded ring of the weak Jacobi form of even weight arbitrary index k in z m z 0, and the theorem claims that this graded ring has two generators of the graded ring of SL2Z modular forms. The first generator, this is the function phi minus 2, 1. The second, phi 0, 1. The proof. You can prove this theorem by induction, and I give you only the main idea, and you can check without any problem the basis of this induction. But now I would like to give you the main idea of this induction. Let us consider an arbitrary function of weight 2k and index m. Then its zeroth value is a modular form of weight 2k. I have to check to change this misprint, weight 2k. In one variable. It might be 0, but in any case, this is a modular form of weight 2k with respect to the full modular group. Now, we consider the following function phi tilde is equal to phi minus, this is our function, f2k tau times 1 over 12 phi 0, I'm sorry, here let us start with phi 0, 1 tau z to the power m with a coefficient 1 over 12 to the power m. What function do we have? This function for that equal 0 is equal to 0 identically. Why? Because the zeroth value of our function phi 0, 1 at 0 is a modular form of weight 0. It means a constant, but this constant is equal to 12 because we have calculated the first zeroth constant term of our coefficient. So this is a constant 12 for that equal to 0. It follows that the Taylor expansion of this function starts from z to the square. F tilde n z to the power n is greater or equal to 2. Because the weight of this function is even, and we have only even powers of that in the Taylor expansion. But we know that the function phi minus 2, 1 has zeros exactly of order 2. And this is the only zero of this Jacobi form because the Jacobi form of weight 1 has exactly 2 zeros in any fundamental domain. Therefore, the quotient is the Jacobi form of weight 2k plus 2 and index m minus 1, and this is weak Jacobi form because we know a part of the Taylor expansion of this function. So this is the standard recursion or induction argument, and now you can use induction on M. Certainly you have to change, or you have to check the basis of this induction, but I leave this, the formulation and the proof of the basis of this induction for you. So you see that using the differential operator, we can construct the generators of the graded ring of the weak Jacobi form. And using our results, you can try to generalize this theorem of Eichler-Zagier to the case of Jacobi form in many variables. So generalization. Of this theorem. Let's put the same question about the weak. Maybe I write it as a term. Graded ring of Jacobi forms for the lattice L. And graded ring certainly of weak. This is very important. So let me add this. Weak Jacobi form, because if you consider the graded ring of all holomorphic Jacobi form, this ring usually has the infinite number of generators. For example, I don't like to prove this theorem, but for many root systems you can find the graded ring of weak Jacobi form if you add some condition of symmetries. For example, let us consider the following Jacobi form for the root system Dn. We can construct a weak Jacobi form of weight minus n for this lattice. By definition, this is a product theta z1 over eta cube in eta till theta in zn over eta cube in eta. So this is a weak Jacobi form of weight minus n for the lattice dn. And this function is also symmetric. Symmetric in a sense, then any permutation of that one, zn, gives us the same function. I don't like to formalize this definition, but this is more or less clear in this case. And if we consider symmetric function, then now you can use the differential operator for this lattice dn, and you get a Jacobi form of weight minus n plus 2 for this lattice. It's again a symmetric weak Jacobi form, but its weight is minus n plus 2. Please find its Q0 Fourier coefficient. Using this argument and this procedure, you can really try to analyze the graded ring of weak Jacobi form of arbitrary weight for the lattice dn with arbitrary index m. So here I also put star. This is a graded ring, G, K, D, N, star, weak. And all these functions, we consider only symmetric function. So please, to analyze this gradient ring, it's possible to find all generators, and this is very, very good exercise which you can make using the theory we consider it. And this question is very close to the modern mathematics, because the same question for the unimodular lattice E8 is still open, or almost open. Now I can add another exercise. I can come back to the previous case. Sorry. And I can add the following exercise. Try to find that the gradient ring of all weak Jacobi form of Eichler-Zagier type is the quadratic extension of this gradient ring, and for the generated function you have to take the Jacobi form of weight minus 1 and index 2. This is the function theta into z over n cube in theta. Moreover, please find its quadratic equation for this function in terms of phi 0, 1 and phi minus 2, 1.